All right, so we are taking our factoring knowledge and our simplifying skills, and we're going to apply them to a new section, and we're actually going to jump up to chapter 12, and we're going to talk about simplifying rational expressions. So before we actually talk about this process, obviously we're going to define what a rational expression is, what it looks like, and then we're going to work with them and simplify them. And to simplify a rational expression, which once we discuss what it is, you'll know what I'm talking about. It involves the factoring method, and it involves the flow chart that we talked about last week. So keeping your factoring flow chart handy is very helpful, and it's going to help you remember the process and help you be able to simplify some of these problems that we're going to talk about today. So first, vocab. A rational expression can be written in the form of a polynomial over a polynomial, meaning a polynomial divided by a polynomial, okay? So a rational expression, it can be written in the form of a polynomial divided by a polynomial. So it's very vague in the sense that it can be any polynomial divided by any type of polynomial. So it could be a monomial, it could be a binomial, it could be a trinomial, it could be, any type of polynomial divided by a polynomial. So we're going to work within, it's going to be set up like a fraction, as you can see some of these problems are. So we're going to work with the numerator and work with the denominator separately, and then we're going to look at them both together, and you'll kind of see what I mean here in a second. So remember, in your GCF factoring flowchart, the first thing you always want to look for is a GCF, right? And then you want to look to see if you have any special patterns, see if, how can we simplify this? How can we factor it? How can we break this down? So first example, we're just going to look at the numerator. We're not looking at the denominator right now, so just in the numerator. 6x plus 12. Well, in 6x plus 12, does it have a GCF? Yes. What is that GCF? It's going to be 6. So I'm going to rewrite this. Equals, I'm going to factor out, I'm going to throw my division bar in there, okay? I'm going to rewrite my denominator because we're not working with our denominator, staying the same. I'm working with the numerator, so the numerator, I'm factoring out this 6x. Now again, it's just staying in the numerator, so I'm factoring out 6. I'm going to be left with x plus 2, okay? And something I want to quick talk about on the side is when we're simplifying fractions, okay, so before we continue any further, we're simplifying fractions. And let's say we have 12 over 18, and we need to simplify that fraction, okay? How do we simplify that? Well, we know they're both divisible by 6, right? And that's kind of how we would proceed. We would go, okay, well, we'd get 2/3, right? Let's look at this a different way. Let's break down 12 into a factor tree. So if we've got a factor tree of 12, so we've got 2 and 6, and 6 is 2 and 3. And then let's do a factor tree of 18, so we get 2 and 9, 3 and 3, right? So then let's rewrite this fraction using our prime factorizations. So we have 2 times 2 times 3 for our 12 over 18, which is going to be 2 times 3 times 3. Now, because we're multiplying all of these numbers together, we can actually cancel out some of the terms that you see in both numerator and denominator, okay? So what does that look like? We have a 2 in the numerator and 2 in the denominator. I can take one out from either one, right? I have another 2 in the numerator, but do I have a pair in the denominator? Do I have a matching 2 in the denominator? No. So I'm going to leave that 2 alone. I can't cancel it out because it doesn't have a partner to cancel out with it, okay? Then I look at the 3. Well, the 3 has another 3, so I can cancel out the 3's. Okay, again, because we're multiplying our terms together, we can find a pair and cancel them out. Okay, let's look at the numerator. What do we have left? We have 3 left in the denominator. Does the 3 have a pair? Does it have a partner up in the numerator to cancel out with it? No, so it stays there. So as you see, you're going to be left with that 2/3, which is the same thing you got using the previous method that we always know how to use, okay? It's just a different way of simplifying. So we're going to use this idea, but with polynomials. So this is going to be a little challenging to you to kind of see it as one term, but the 6 is being multiplied times the x plus 2, okay? You can think of x plus 2 as one term. So because you have an x plus 2 in the numerator and an x plus 2 in the denominator, they're the same, you can cancel them out. Again, you can only do that because you're multiplying the 6 times the x plus 2. When you cancel them both out, guys, what's left in the denominator here? Do I just leave it? Is it going to be 0? No, you're going to leave it as 1, so you get 6 over 1, which is 6. So your final answer here is going to be 6. That's the simplified solution. Okay, so let's try it again. We've got 12c squared over 3c plus 6. So I'm going to go equals, draw my line. All right, look at the numerator, 12c squared. Is there anything I can simplify there or factor out or, clean it up a little bit? It's one term, so there's nothing I can do. So it's going to stay the same, 12c squared. We have 3c plus 6. Is there GCF between those two terms? Yeah, you're going to have a GCF of 3. So you're going to factor out the 3, and you're going to get c plus 2. Okay. So now what? I don't have a c squared in the denominator, and I don't have a c plus 2 in the numerator. But we have a 12 and a 3. What's 12 divided by 3? You get 4 over 1. So your final answer is 4c squared over c plus 2. Okay? So again, because c squared didn't have a partner in the denominator and c plus 2 didn't have a partner in the numerator, you can't cancel anything else out here, but you can simplify your coefficients. Okay? Similar to what we did in this fraction problem. Okay, so here we go. Let's do it again. We have another rational expression. Okay. Draw my equal, draw my line. Let's work with the numerator first, and then we'll work with the denominator. So work with the numerator. 2x minus 12. Well, does 2x and 12 have a greatest common factor? Yeah, they have a greatest common factor of 2, so I'm going to factor it out, and I get x minus 6. Okay. Now I'm going to look at my denominator. That's a polynomial. It's a quadratic, actually. But do you see a pattern? Can we factor this polynomial? And the answer is going to be yes. So see if you can dig in your brain. See if you can use your factoring flowchart. See if you can figure out how we're going to factor this guy, right? Coefficient is 1, so in front of the leading coefficient is 1, so the number in front of x squared is 1. So I break it down into x and x. Looking for factors of 6 that add up to negative 7. So I'm going to get minus 6 minus 1. Okay? Now what do you notice? Do you have something in the numerator that's the same as the denominator? Yeah. You've got the x minus 6. So they get canceled out. You're left with 2 over x minus 1 as your final answer. Okay? So, next one, here we go, equals, line, right? Work with the numerator and then work with the denominator. So work with the numerator. I'm going to actually cover up the denominator so that way we're not confused by it. We've got c squared minus c minus 6. It's going to be factorable. I get c and c. And I need negative 1c, but factors of negative 6. So I'm going to go negative 3, positive 2. Again, if you need to write it out on the side, write out the factors of 6, write out the factors of 6, okay? That'll help you visualize what your factors are going to be and what your terms are going to be. Now we're going to work with the denominator. So I'm going to go ahead and cover up the numerator. And we're going to work with just the denominator. We have c squared plus 5c plus 6. So we've got c and c. Well, to get 5 in the middle, we need plus 3 and plus 2. Okay, what do you notice? What's the same? Our c plus 2's are the same. We're going to be left with c minus 3 over c plus 3. Okay, and remember, we can't cancel these out because they're not 100% identical. This one says -3 and this one says +3. That's a big difference. Okay. All right, so that's simplifying rational expressions. Now we're going to continue to simplify rational expressions, but we're going to talk about something else that's a little more key, that is still key and a little bit more important. It takes factoring to the next level. Okay, so again, what I want you to do is just work with the numerator and then work with the denominator. So let's work with the numerator first. Here we go. 5x minus 15. The have is GCF of 5, so I get x minus 3. Okay. Now I want to work with the denominator. I've got 9 minus x squared. Well, question. If I have 1 plus 3, that gives me 4, right? Isn't that the same thing as 3 plus 1? You get the same place. Okay, bear with me. Here we go. We've got, let's go, 4 minus 2. Gives me 2. But I can also get 2 using 4 and -2 with -2 plus 4, right? Using same numbers, different order, and I'm still going to get 2. All right, so keep that in mind. Does this look like something that you would recognize from factoring? It should look like a difference of 2 squares, but kind of backwards than what you're used to. So there's a couple different ways you can do this. It's still difference of 2 squares, so you can still factor it out as is, okay? Or just switch the order. So you're going to have negative x squared plus 9. Again, same thing. All I did was take the two terms and I flipped them. My x squared has to stay negative and my 9 has to stay positive because that's what this says. Now, this is not a difference of 2 squares anymore because I'm adding 9. But what if I factored out a -1? That would make the x squared positive and make my 9 negative. So I have 5 times x minus 3 in the numerator. Again, nothing changed. But this time in the denominator, I'm going to factor out -1, and then I have x squared minus 9. Well, x squared minus 9, I know how to factor that. That's a difference of 2 squares. So here we go. 5 times x minus 3, numerator stays the same. I've got my -1, 2 sets of parentheses for my x squared minus 9. So my x squared minus 9 becomes x and x plus 3 minus 3. What's the same? X minus 3 and x minus 3, so what are we left with? 5 over -1x plus 3. Done. Okay. Let's do it again. Numerator and then the denominator. Numerator. Our r comes after our constant. That's not something we're used to. So let's flip the order similar to how we did right here. So I'm going to flip the order. My 4r stays negative and my 8 has to stay positive. Okay. And then, you know what? Let's go ahead and work with the denominator right away. We can do several things at one time. 2 sets of parentheses. We want to go ahead and factor it out, right? So you get r and r. We need -8 but +2. So -8, +2. So we're going to go plus 4 minus 2. Okay? What do you notice about the numerator? Nothing's matching up here, right? Does the numerator have a GCF? Sure does. Factor out and -4. So you're going to get r minus 2 over r plus 4, r minus 2. What do you notice? R minus 2's. -4, r plus 4. And you're done. Okay? The toughest part about this is being able to factor. Okay? So if you're still a little rough with factoring, go back, watch the previous lessons with factoring, or reach out and shoot me an email and let me know, and I'll give you some alternate videos are alternate practice problems for factoring, so that way this becomes much easier and much simpler. So I think the toughest thing about this is knowing how to factor and when to factor, okay? And then understanding why we can cancel things out. So you want to look for things that are the same.